All right, so this one says Laura and Kennedy are at softball practice. Laura hits the ball that is 3 feet above the ground with an initial upward velocity of 60 feet per second. Kennedy hits a ball that is 2.5 feet above the ground, and the initial velocity upward is 55 feet per second. If x is time and y is the height of the ball, and the acceleration due to gravity is negative 32 feet per second, which system of equations models the projectile motion? So the one thing, in order to do this, you kind of have to know the free fall equation. Luckily for you, I'm a physics teacher too. So the free fall equation, that's not the best Q. Let's make that look like an actual Q. So the free fall equation is the height of the ball y, minus 1/2 the acceleration due to gravity times time squared, right? Plus the velocity times time, plus the initial position, which in some cases this would be like y final, and this would be like y initial, which would be the height. Okay. So anyways, if we were to rewrite this in terms of x, you would say y equals negative 1/2 times a times x squared. We're just replacing the t's with x. Plus v times x plus the initial y. And then the final y. So we've got two things. So for Laura, it says that her initial position is 3 feet, and she has an upward velocity of 60 feet per second. And her acceleration, the acceleration, both these are going to be 32. And that's okay. And then for Kennedy, her initial condition is 2.5 feet, and her velocity is 55 feet per second, and then her acceleration due to gravity is going to be 32. Now, I wrote the formula with negative, so let me clarify this. There's only one negative sign, all right? So in free fall, I always write the negative sign, but some textbooks just let the negative sign be the actual acceleration due to gravity. Technically, this is right. And if we're going to let this be negative 32, and we're going to let this be negative 32, then we don't need the negative sign in the formula. The negative sign just denotes that we're going down, right? So if you think of an XY graph, going up is positive, Y going down is negative. So you want to have that first term be negative. So anyways, so for Laura, so now we got to write a system of equations that models both of these. So for Laura, I've got y equals 1/2 of 32, negative 32 is negative 16, x squared plus the initial velocity of 60 times x plus the initial height, which is 3. For Kennedy, we've got y equals negative 16 x squared plus 55 x plus 2.5. And that is basically it on that one.